That's the next step. All right, plating, that's the next step. You want to do a plate count, you got to put stuff on the plate to count it. So that's what we're looking at here. We have our PCA plates. PCA stands for plate count agar. Where did they come up with these names? All right, and now you see we have pre-1, this is 10 to the minus 3, minus 4, minus 5, and minus 6. Now you'll also notice that this is PCA plus ampicillin. That's why the amp is there. There we go. All right, so the ampicillin is a broad spectrum antibiotic. It is used to treat, well, all sorts of stuff. And in this scenario, we suspect, or you suspect, that the pathogenic bacteria that you're working with or that is in the water might be ampicillin resistant. The reason you suspect this is because the people are not responding to treatment with regular antibiotics. Now, typically this is not exactly how this scenario would go because we're talking about a toxin that's made by the bacteria instead of an infection. Not important. What we're doing is we are looking at antibiotic resistance and selective media, and that's why we're combining these two things. Okay, so the point of all of this is that you are dealing with bacteria that you suspect might be resistant to ampicillin. Antibiotic resistance is a major problem. It's like an arms race. We come up with new antibiotics, put them out there. Bacteria, they are subjected to them. Some of them evolve and survive and go on and become resistant to those antibiotics, and so we have to come up with new ones over and over again. Okay, so this is sort of demonstrating how that works. And here's how we're going to do to plate it. Okay, so to begin with, what are we actually plating? We have the original sample. We have 10 to the minus 1, 10 to the minus 2, minus 3, minus 4, and minus 5 in our dilution series. We take a look here. We have 10 to the minus 3 for our plate, 10 to the minus 4, 5, and 6. Well, that doesn't make sense. We have 1 through 5 here, but on the plates we have 3 through 6. Okay, so the reason we're doing that is pretty simple. We are going to be putting on these plates 1/10 of a milliliter, or 100 microliters, which is as low as this thing measures accurately. You can take it down further, but it doesn't measure accurately. It's not built for that. We are at 100 microliters here. Okay, so here's the thing. All of these numbers that we have here, we are ultimately looking for a microbial load of X number of CFUs, colony-forming units per milliliter, right? Okay, so since we're looking at things per milliliter, if we are adding 1/10 of a milliliter to our plates, then we have to take that into account as well. If we were adding a milliliter, then whatever sample we use, we'd use the same number here. But we're only adding 1/10 as much, and that is why our plate numbers are 1/10 the numbers of the sample that we're putting on it. So with that in mind, 10 to the minus 3, we are adding which tube? Yes, that is correct. We are adding the 10 to the minus 2 sample onto it. And how much are we adding? 100 microliters, or 1/10 of a milliliter. Okay, hopefully that makes sense. And here's how we do it. Take your plate, you turn it over, put the other ones out of the way, because we're going to be, well, dispensing stuff onto it. Okay, make sure everything is ready to go. Go and get your tip. Make sure it is sterile. And some of you may have read an older version of the manual that says that we're going to be starting at the most dilute and working up. We're not going to bother with that. It complicates things. It makes it more likely you'll have cross-contamination. But most importantly, if you're not working quickly enough, then it's very possible, especially in the winter where the air is dry, that your first sample will dry out on the plate and you won't be able to spread it. So, first thing we're going to do is we're going to take 100 microliters of the stuff from the 10 to the minus 2 tube, and we're going to dispense it onto the surface of the 10 to the minus 3 plate. You can see this doesn't look like a whole lot there. We set that aside. We want to work quickly here. We get a new tip. We get our 10 to the minus 4 plate. And which tube are we using? Yes, 10 to the minus 3, because we're adding 1/10 of a milliliter to this plate. Okay, take a look. Make sure that there are no bubbles here. It is more important to be precise because we're dealing with a smaller volume. Okay, so go ahead and pop that on there. New tip. 10 to the minus 5. We're using the 10 to the minus 4 tube. Okay? Depress. Go in. Draw. Double check. No bubbles. Pop it on there, and if you can sort of spread it out a little bit, go ahead and do that. Don't touch the surface of the agar with the tip. 10 to the minus 6. Tip. Go into the 10 to the minus 5 sample. Draw. Make sure there are no air bubbles. We're good. And then dispense. Okay. That's it. We've put 1/10 of a milliliter on each of our plates here. Now to spread them. It's a spread plate. Of course, we're going to spread. Set everything else out of the way. Make sure that your plates are here. Now, if you are not sure that you'll be able to work quickly enough, you can do the plates one by one, put the sample on them, and then spread them. Might not be a bad idea. We are sort of pressed for time though, so we want to work efficiently. Here are our spreaders. Right now, the one that will be on your bench will be sterile. If it's opened, it's not, we can't guarantee it's sterile, so just put it on the instructor bench or the demo bench and we'll get you a new one. Okay. So, you go in, you take one out when you're ready. Okay, so, let's go ahead and tilt this down, and I'm actually going to lower the camera a little bit. Bring this a little bit closer, not that close. All right, so you can see we have our plate here. You can see the sample is there, and it is not dried out, but it has stained the surface because we're talking about crystal violet here. All right, so, but that's sort of an illustration of if you take too long, your sample will just end up in one place, not spread out. You won't end up with a spread plate. You won't be able to count it properly. It's just bad news. Okay, so what we want to do is you put your spreader down and you just sort of turn it, okay? Then you can turn it over and do it again, sort of move it around. You just want to spread things as evenly as possible across this surface, okay? So the last thing you want is to have just a big chunk somewhere that's not spread out, or you won't get a good count. Okay, so after you've done that, go ahead, set it aside, you toss your spreader in the Dettol, you're good. Go to the next one. Okay, again, grab the spreader, and we're going in. Okay, so just turn it, just sort of spread things, you can swirl it around a little bit. Sometimes it works well, sometimes it doesn't. You can go the other direction. You just want to make sure that you don't end up with a bunch of stuff caught around the edges. It's very easy to do that, so make sure that you're actually touching the edges and bringing things out. Once you're done with that, toss it. Okay, now let's do one without the fancy turntable. This, of course, is a little bit more tedious. What you might want to do is just sort of wait while, if you don't get it, your partner has it, or someone else at the table does. You can wait, but it's not terribly difficult to spread it without. You can do it by hand. Just sort of spread it around, turn it, spread it some more, turn it, spread it some more, flip it over, spread it some more, turn it, and just get it nice and spread out like that, okay? Once you're done, toss it on the Dettol. You'll do all four. Once you've done all four, you have them upside down, of course. You tape them together. We're going to incubate them. And in 24 to 48 hours, we should see colonies growing on these. We are looking for individual colonies. We will look for the plate or plates that are best in terms of countability. That means nice, even spread. Individual colonies not ones that are clumped together where it's hard to tell what's what, and between 30 and 300 colonies. So we'll see some examples of that. You'll be able to do this once that's done. Then we'll go on to the other exercises of the day.